Your garden soil is exhausted, and synthetic fertilizer is a subscription you never stop paying. You feed it, the rain washes it out, and the clay underneath stays just as dead. So today we stop patching the symptom. We're going to reverse engineer a thousand-year-old soil technology, weld a primitive kiln in an afternoon, and turn woody waste into a permanent carbon sponge that fixes the clay for good. Here's the core mechanism, and it's elegant enough that industrial reactors can't beat it at small scale. It's called flame cap pyrolysis. The fire on top burns off the smoke and volatile gases, and in doing so, it consumes the oxygen so the wood underneath the flame doesn't turn to ash. It bakes. Starved of oxygen at temperatures north of 500 degrees, the wood can't combust. It carbonizes instead, locking its carbon skeleton into place. The flame is the lid. That's the whole trick. Construction is deliberately low-tech. We're cutting cone panels from scrap steel plate thick enough to survive repeated high-heat cycles without warping, and welding the seams into a single open cone. No sensors, no sealed retort, no moving parts. And that primitive geometry isn't a compromise. The open cone is what creates the self-regulating flame curtain in the first place. A sealed industrial reactor needs pumps and controllers to do what this shape does with nothing but physics and a good weld. Now we run it. We source local woody waste, prunings, deadfall, offcuts, and load the kiln in layers, letting each layer catch before adding the next. That maintains a consistent flame curtain across the whole surface, and we don't need a thermometer to read the burn. We read the smoke. Thick white smoke means it's still off-gassing moisture and volatiles. As it shifts to thin and blue, then nearly clear, that's your signal. Clean combustion, and the carbon underneath is carbonizing at peak porosity. Timing the finish is everything, and this is where most people ruin the batch. Keep burning, and your porous char collapses into ash. So at the critical moment, the instant the char is fully formed, but before it turns to ash, we quench it with water. That thermal shock freezes the microscopic honeycomb in place, and that structure is the entire point. A single gram of this char can unfold to hundreds of square meters of internal surface area. That's the sponge we're building. But here's the catch. Nobody tells you. Raw biochar will wreck your soil first. Fresh out of the kiln, that char is a blank sponge, and a blank sponge doesn't give, it takes. Drop it in raw and it strips nitrogen out of your soil to fill its own empty pores. So we charge it first. We brew a high-potency compost tea, teeming with microbes and minerals, and submerge the char in it. The pores flood with life. Every one of those hundreds of square meters becomes real estate for a living microbial colony. Now the sponge is loaded and ready to give. Now we heal the clay. Over-farm garden clay has two failures. It's compacted, so air and water can't move, and it leaks. Every rain flushes the nutrients straight through. The charged biochar fixes both at once. Worked into the profile, the granules create permanent aeration and moisture reservoirs, structure that doesn't compact back down. And that same pore network that was stealing nitrogen a minute ago now holds nutrients against the rain instead of letting them wash away. The roots finally have somewhere to breathe. And the results compound. The immediate shift is in tilth. The soil goes from cracked gray to dark living crumb, with a visible surge in plant vitality across the test beds. But the real payoff is the timeline. You've converted woody waste that would have rotted and released its carbon into a soil amendment that stays stable for centuries, while it quietly ends your dependence on synthetic inputs for good. Ancient fire, scrap steel, and biology out-engineering the fertilizer aisle. Store the carbon, charge the sponge, and stop renting your soil's fertility. See you in the engine room.